Hi, my name is Miss Pat, and I'm a teacher at the Boone County Conservation District. And today we are going to talk about biomimicry. So what is biomimicry? Well, it's made up of two words, bio meaning nature or life, and mimicry meaning to copy. So biomimicry is copying nature. And why would we want to do that? Why do we want to copy nature? Well, nature is pretty smart, and they have come up with many ideas and solutions for different problems. They have ideas in nature are very efficient. They don't waste things. Nature doesn't waste things. And things that don't work in nature, you as a species or a plant or an animal are not going to survive. So biomimicry is copying what nature has already determined works. So we just have to adapt it to our situations or our problems. And that can help us use less energy, use less chemicals, and use less of our natural resources so that we have enough for our generation and for all the people that come after us. So, what are some things that we have done that use biomimicry? Well, one thing is, can you see this jaguar? Well, he has spots. And because of his spots, he's very well camouflaged when he's going around in the jungle. Well, I copied the idea of camouflage in clothing and jackets and anything that we want to try and keep hidden when you're moving out in nature. So you can wear camouflage. Down here, this is called an acorn weevil. And the acorn weevil uses its snout to drill holes into this acorn, just as we are using this drill to drill holes into a birdhouse or whatever else you might need to drill a hole into. Another idea that we copied from nature is the kangaroo pouch. So the kangaroo has a pouch in front to carry its baby. And here, this mother has what I think is actually called a kangaroo pouch baby carrier, and that carries the baby in the front, just like the kangaroo does. So we copied that from nature, and that is biomimicry. This is a really good one. Do you know what this is? This is called an ice hammer. And people that are climbing glaciers use it to hold their place in the ice. So they pound that in, and that helps them move up on the glacier. And this ice hammer is almost the exact same shape as this woodpecker. The beak looks just like that, doesn't it? And the head. And that's because this shape and this design works really well for pounding things. The woodpecker is very efficient in getting into that wood, and that allows this ice hammer to also be very efficient in getting into the ice. So one of the most famous biomimicry designs was done by this man. Do you know who this is? Probably not. This gentleman's name is George DeMestral, and he and his dog were out walking one day, this is a long time ago, in the 1940s. And when they came back, he noticed on his dog and on his pants, there were all of these little cockleburs. Can you see those? All those cockleburs. And they're even stuck together. They were stuck on his dog's fur and on his pants. And he wondered why they stuck so well. Because if you've ever had them on your pants after a hike, you know that they can be really hard to get all of the little hooks and that off, to get all of the little plant parts off. So Mr. Demestral decided he was going to look at a cocklebur under the microscope and see what he could see if he could figure out why they stuck so well. Well, when he looked under the microscope, he saw the cocklebur had all of these little hooks on it. And those hooks grab onto the dog's fur or your pants or your mittens and make it very hard for you to get those off. So he decided that that might make a really good fastener for clothes. Easier to use than a zipper or buttons. And so he spent a long time, almost 15 years, developing this fastener that we could use in place of zippers or buttons. And what he developed is we call Velcro. And this is a magnified version of Velcro. So you see, it's got the little hooks, just like the cocklebur had the hooks, the Velcro also has hooks. And then the other side is loops. And these loops are much smoother. So this is what he developed. And it came out in the early 1960s, and people didn't like it. They thought it was weird, and they didn't know what to do with it, and it just seemed strange. But then the space program started using it, and they thought it was perfect for space because they could put the hook part on a table or whatever they wanted it, and then they could put the loop part on your pen, and you could stick your pen to the wall or the table wherever you wanted, and it wouldn't float around like it would do in space if it wasn't attached to anything. It worked very well in space. So what I would like you to do is you need a piece of paper and a pencil, and I want you to go around the house and see how many things you can find that have Velcro on them. Now, you can't count, if your shoe has 3 strips of Velcro on it, you can't count that 3 times. You can only count it once for your shoes. But Velcro is on all sorts of things. And see how many you can find, and then write them down on the paper. Okay, did you find lots of things? I bet you did. Because Velcro is used on shoes, it's used on pants and snow pants, boots, mittens, not on zippers, in place of zippers, suitcases, all sorts of things. You can find Velcro, you can buy it and use it to stick things on the wall, all sorts of things. So I have some Velcro right here. And you can always tell it's Velcro because it always makes that noise, right? When you open it, Velcro always makes that noise when the 2 parts are coming apart. So I want you to take one of your items and open the Velcro, and then close your eyes and feel both sides of the Velcro. They feel totally different, don't they? One side feels kind of hard and plasticky and even kind of pointy a little bit. And the other side feels smooth and much softer. And those are the 2 sides of the Velcro. The hooks are the hard part, and the loops are the soft part. And that's what makes Velcro work, is that they stick together and they don't come apart, except when you do that. So what I'd like you to do for your last thing on Velcro is look closely at it. And if you look at it very carefully and you kind of tip it a little bit back and forth, you can see the hooks. So see if you can see the hooks on this side and the loops on the other side. And then I want you to draw a picture on the bottom of your paper of what those 2 things look like. Remember, these are the hooks and these are the loops. So that's what it looks like. So Velcro is a very important invention, and it was discovered from nature, so it is biomimicry. Okay, so Velcro is one form of biomimicry, copying from nature. Another thing that we have copied from nature, humans, are tools. We have copied a lot of tools from nature. And especially, we've copied tools from bird beaks. Now, if you think about it, you think, oh, bird beaks, they're not that different. But that's not true. There's lots of different bird beaks. So I have 6 birds with 6 different types of bird beaks. And we are going to determine which tool is most like that bird beak. Okay? So here are the birds. The first one is a cardinal. See, and when I'm showing you these pictures, look at their bird beaks and see how different they are. So this one is kind of like a triangle. This is a hummingbird with a long, thin bird beak. This is a nuthatch. Nuthatches like to climb up and down trees this way and this way. And they have also a skinny beak, but it's much narrower and not anywhere near as long as the hummingbird. And then we have a robin, which has a long beak also, but it's wider and fatter than the nuthatch. Then we have a duck who has a flat beak, and it actually has holes in it that it can drain out water. And then we have our woodpecker, and they have a long, thin beak so they can get underneath bark to find the grubs that they eat. And I just gave you a clue as to why there are so many different bird beaks. The bird beaks are all different because they are adapted. The birds have developed their beaks over time that help them best to eat the foods that they like. So different birds have different beaks because they eat different foods. Okay, so as you can see, I put the birds up here and labeled them 1 to 6. Now, what types of foods do those birds like to eat? Well, cardinals like to eat seeds and nuts, so they have a beak that can crack open seeds and nuts. Hummingbirds like to get nectar from these plants, and these are long and thin, so they need that long, thin beak to get all the nectar out of the flower. Nuthatches eat little bugs. You see, there's little bugs here on the log, and they have a little beak that's small enough to pull those bugs out of the bark. Robins like to eat worms, and so they have a beak that allows them to go into the dirt and pull up the worm, into the dirt and pull up the worm. Not just worms right on the surface, but they can get down in. Ducks like to eat water plants, and so they have a beak that allows them to scoop up the water plants, drain the water out, and then they eat the plants and get more nutrients because they can eat more plants instead of just swallowing a lot of water. And lastly, our woodpecker likes to eat grubs. And those grubs and insects in that are under the bark. So that's why they peck at a tree so that they can find the insects underneath the bark. So they have a hard, long, thin beak. Okay, as you can see, we've got the birds up. We have the foods that they eat right next to them. And now we are going to determine which tools we humans copied from the bird beaks. And I have 6 different ones that I've picked out, and I'll show you them one at a time. And then I'm going to put the pictures of those tools with their names and a number up on the board. So first we have a tweezers, and those You know, you can pick things out, you know, you can get a sliver out of your finger or whatever with the tweezers. We have a skewer, and it's got a pointed end, so you can poke at things and get things out with a skewer. This is a spoon, and it has holes in it, so it'll drain the water out. So this is a spoon that you can use like this. Gotta kind of pretend that part's not there. Then I have a nut cracker. So you can put the nut in there and then you squish it down and that will crack the nut. I have a straw. You can either put it in the liquid and pull it up, or you can drink from it and suck it up that way. And then this is tongs, and they can go down in quite deep and pull things up. So those are the tools. And before we get started with our actual experiment of me showing which tool works the best for which food, I want you to make a chart. So here's our little chart for the tools. So as you can see, I've written tools on the top, and then I numbered it 1, 2, 3, 4, 5, 6, and then I put before and after up here. And I made just a line there and a line there. And what we're going to do is we're going to, before I do the experiment, the actual experiment, you're going to guess or make a hypothesis. That great big long word means that you try and guess which tool is going to work that I put up there. And if you think it's the nutcracker, well, the nutcracker is number 4. So you are going to write number 4 by number 1, because that's for the first row. And then you're going to pick which one you think will be best with the hummingbird and the nuthatch and the robin and the duck and the woodpecker. So you are going to guess which tool will work the best. And each tool can only be used once. Okay? So write those down. Okay, so as you can see, I have 6 different food types here. And we are going to determine which tool works the best. And all of these food types represent what types of food the birds eat up here on the board that we already talked about. So the first one we have here are our pistachio nuts. And which tool do you think will work the best? And if you said the nutcracker, you are correct. Okay, so let's see if it works. Oops. So if we put the nut in and then we crack it, whoops. Yep, I would say that worked pretty good. We cracked the nut wide open, and so the bird could eat that. So number 1, the cardinal, who eats nuts, their beak is most like a nutcracker. Number 2 is the hummingbird. And what tool do you think? That would be the straw. And the straw can go in and get the most nectar all the way from the bottom. It's the only one that can do that. And then we have our nuthatch with getting the bugs off of the log, and that would be our tweezers. The tweezers works the best for getting all these little bugs or pieces of rice off of the log. Even this difficult one right there. There we go. We get them all off. So that's the tweezers. Okay, we've used 3 tools. Now we only have 3 left. So what do you think will be the best to get the worms out of the dirt here? Well, that would be the tongs. Because if you go all the way down, you can get a worm, right? Should see if we can get another one all the way down. And sure enough, there's the other one. So that's the tongs. Now we have to get the water plants, and we only have two left. We have a skewer, and we have the teaspoon for straining tea that's got the holes in it. And which one do you think? And if you said the spoon, you would be correct. See, it just scoops them right up. Scoops them right up. So that would work the best. So that would be for that one. And then we have the skewer. And so that's the one that's going to be most like getting the worms out or the bugs out of the log. And there we go. We have our bug to eat out of our log. So that's for the woodpecker. Okay, so you can take your paper and write down the correct answers in the after column. So number 1, 4, 5, 1, 6, 3, 2. I'm reading through the back of the paper and it was hard to tell which was which. So now, if you didn't get everything right in your before answers, like I had these two turned around, that's okay. Scientists don't always get everything right the first time. So you just do another experiment and see how it goes. You learn to redo what you've done and see where you can make improvements. So that's all there is. I hope you enjoyed learning about biomimicry, and that the next time you're outside, you might look around and see if there's anything that you could make an invention of. So you could have the next great invention for biomimicry. So I hope you enjoyed this and that you will watch some of our other videos on different things.